Hello there, let's do serialize and deserialize a binary tree. In this particular problem, we are given a binary tree, and what's going to happen is that we're going to serialize it into a string and then take that string and turn it back into a tree. So what we're going to do is pre-order traversal. So if you can see a pre-order traversal, let's check this out. 4 and 5. As you can see, if we do a pre-order traversal, we do the 1. Then we look at the 2. Of course, there's going to be a left, root, left, and right. Then, I think actually it goes like this. Top node, left, top node, left, so that's a none. And then it's going to be a none again on this other side. So there's none here and none here. Then we go to the right, and then we go to the left. So 5, and then we have none again, and a none again. So 2 nuns. And then we go back up to 3, and then go to 5, and there's 2 other nuns here. So 5, and then none, none. With that, if we traverse the same way again, then we would be able to recreate our item. So what's going to happen is, if we take the first item, we turn it into a node. Then what's going to happen now is we're going to move forward and take the second item. And then we're going to go left again, and that's going to be none. And then we're going to go right again. That's going to be none. So now we have done with 4 items. And we move forward one more time, and we get a 3, right? So with the 3, then we move it over one more time. We go left. We have a 5, and then we go left again. And we have an n. And we go right, left, and again. And then we go right, so which is going to give us 5, and then we're going to have an n and another n again, and that's going to be end of our array, where I is equal to the end of the array, and we're done. So yeah, let's do it this way. So first of all, to encode it into a single string is to traverse. So let's create results, empty an array. So define a DFS of root. So if not root, we're going to say results dot append an, and then return. Otherwise, we run DFS on root.left and DFS on root.right. Before that, we do need to append this item to our results. To append this item, we are going to make this a string. We could stringify it later, but meh. Okay, whatever. So we do it now. Then we run through our DFS calls, and then we're done. So we did a pre-order traversal and added all the items in, and now we can return we can join this with any delimiter that we want. We can just join it with a comma, and we'll join the results into a string, and we'll return it. Okay, now we have a string, this particular thing over here, and we need to turn it into a result. So first things first, let's turn this into an array of numbers, or like n's. So what's going to happen is that if we see an n, like, well, we don't need a root here. So if we see an n, Okay, we're going to set the I plus equals 1. So we need a non-local I equals 0. So we're going to increment through our array, and we could pop things off, but we're using an I, so we could do this. So now what we're going to do is return none. Okay, with that, we can just return. Actually, we're not doing anything. So now our root is equal to data at I. Actually, that's going to be a tree node at data at I. So that means that we need to separate this. So data dot split at comma, and then we're gonna do a map with a lambda function of x, and that's if an int of x, well, string of x, int of x if x does not equal n, else n. And then we do the map, and then we turn that map into a list. And with that, we will always be getting an int for I, and turn that into our value. So root.left is equal to the DFS of like root.right is equal to DFS, and we're gonna return the root, this particular root right here. The DFS will, what they will do is that they will get this particular root. Yes, this is looking quite strange. Alright, with that, we return our DFS call with the root, and let's submit this. So there's an issue with a lambda function, and I wonder what's wrong. Right. The problem is that we did not call our DFS call here, and that's why it's empty. Okay, maximum depth. Right. We also forgot to increment the I, because that's important. We can also pop the item out. So that's another method. Let's try that. Well, let's see. Data.pop 0. Data.pop 0. I wonder what happens here. Looks like it works. Oh, it worked. Okay, and it's pretty fast too. So we popped the data out this time around, and would not, I guess, go through array and iterate the I. I thought iterating the I would be faster than to, I guess, change our array. But it seems changing array is a little faster. But yeah, that's it. Pretty interesting problem. We could do this with a stack as well. So we could do a while true and a stack. That way we could, operate on the item in the stack at that particular time, also doing pre-order. But this is one way of doing it. It's pretty interesting way of doing it. Anyways, if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.